Okay. So let's have revision of the earlier classes. Not so. Close it off. Now let's have revision of the earlier classes. So we said that there are two major types of the statistical tests. What are they?
You have two men. What?
There are two major types of statistical tests. What are they?
Parametric and non-parametric.
Yes, good. Parametric and non-parametric tests. Good. Now, when are parametric tests used?
When it is normally distributed. When the study is normally distributed.
Good. So parametric tests are used when it is normally distributed. When are non-parametric tests used?
When it is not normally distributed.
When it's not normally distributed. Good. Now, for categorical parametrical test, for a categorical parametrical test, what do we use if we have a large sample size?
Analytical, c'était catégorical,
Yes,
pas numérical.
for
Catégorical, c'était quoi? C'était t-test. Non, non.
yes,
C'était chi-square.
yes, correct.
Chi-square.
This is a chi-square test. Now, if you have limited samples
Mhm.
within the cells, what do we use?
Hmm. Limited sample. Je me rappelle pas pour limited sample.
Fisher test.
Ok. Fisher exact test.
Okay.
D'accord.
So when you want to compare now continuous variables for continuous
Mhm.
variables which are parametric, what do you use?
When you have two means,
Yes,
that's why you use the student t-test.
yes, you use a student t-test. So that's good. Now when you want to compare more than two means, what do you use?
ANOVA.
Yes, we use the analysis of variance for parametric test. Now, if you have now continuous variables that you want to use now instead of non-parametric test, what test do you use?
You have continuous variable but non-parametric.
Yes,
Ça, les noms bizarres, là, je me rappelle pas des noms, là.
yes, you
Puisque
have
les gens parlent de trucs qu'on n'utilise pas quand
Man-Whitney
on
U
connaît.
test, the Man-Whitney U test, the
Manuel.
Coxon test, the
Uh-huh.
Man-Whitney U test, the Coxon test. Now, if you have, we have also the Kruskal-Wallis test. If you have now
No.
multiple means that you want to compare, but inside the non-parametric test, what do you use?
Là, même ça, je me rappelle pas des noms.
Yes, the Commonwealth-Smirnov test. The Commonwealth-Smirnov test.
This, I
Now,
think
if
that,
you have
c'est,
categorical
comment ça rappelle de
variables
ça?
for non-parametric test, what do you use?
Parametric test, non-variable.
There are
Same thing.
specific chi-square tests that are used for the non-parametric categorical variables. There are specific chi-square tests. So we have already discussed about all
Mm-hmm.
those tests. I'm sure you are capable of doing that. Now let's have a brief revision now, so that you are the one to tell me how to perform those statistical tests, both in Python and R. Is it okay?
D'accord, let's try and see.
Okay. Today our main course will be to do the logistic regression and the linear regression. That's the last element of the data analysis. After knowing that, we are complete in data analysis. Okay, so the first thing first, I've already stored this iris dataset such that the iris dataset that we have created multiple variables in it. You remember now?
Mm-hmm.
That iris dataset that we have created, we have added some variables, some categorical variables, such that it can help us to do categorical variables and all the like. So I've already entered it. Now the first thing first, what library must I call in order to read the Excel file? What
C'était
library?
excellent.
Ah,
C'était Excel. Excel
You
itself.
should read Excel.
Library read Excel.
Yes,
Library read Excel.
Excel. Correct. So now when I call the library, I will now place now in within iris 0. I want to add the data set one. I want to add the I will read Excel now, XLS in bracket. Then I come and put the root where that Excel is. And then I put iris 0 dot XLS. Make sure that you convert all this to post to forward slash, else it's going to disturb you. I did not put desktop. Excel is not good. So I have my iris 0 that is has entered. So in order to call now to use the piping, what do we say was the major library that was used for data when you want to do data processing?
Le tidyverse.
Yes, so tidyverse contain everything. So I'll call tidyverse. Okay, good. Now, what was the major library that we said in order to design very beautiful tables?
C'était ggplot.
GT summary.
Okay, GT summary. What's the difference between GT summary and ggplot?
ggplot it was for plotting when you want to do data visualization, and ggplot is already within the tidyverse. So when you are calling tidyverse, you have multiplier, you have forecast, you have ggplot, you have google. Ggplot too is already within the tidyverse. So there is no need of calling the ggplot when you have already called tidyverse. So that's GT summary. Now, let's say that I want to visualize the head of the data set. So I'll write iris 0, then I will pipe it within what? Within the head function. So I have the head of the, or I can just say view iris 0. So I can see now the iris 0. Remember, this was the thing that you have created last time. So I've just thought so that we do not lose our category septal
Yes.
width and category septal length. But I hope that you can see
Mm-hmm.
you know how to create all of them. You know how to create the category SW and category SL. Is were in the previous videos, and I've sent it already in the group. Okay,
D'accord.
so that's that. Now let's come now and do again the chi-square testing. Remember how to create a chi-square?
That's good.
So how do you do chi-square again?
C'était Square, tu choisis ce que tu devais faire. Tu veux le Square sur ça, si je me rappelle.
No.
C'était
What we
chi.
said what we said was to write GT or table summary. The code that we used was table summary. Within this table summary, we
Mm-hmm.
said that what? We said that you are going to pipe in the iris 0 data set. Please make sure that you retain this very well because it's the most important aspect of data analysis. You take the iris 0 data set, you pipe it within the table summary. And within the table summary, you can decide to go by which level. I can group it by category SW. So I'll say that I want to group it by cat SW. Now, the next will be to include. The next will be to include. I should include what? I want to include a set of which particular ones. Let's say that I want to include species, and then I also want to include what? Cat SL. Hmm? So this is just the first table that I just want to produce. I just press enter. You see now. Are you getting?
Mm-hmm.
So you see here that when you write that GT summary table, it's going to pick the characteristic as species, category SW, and it's going to divide it among those with large sepal length and small sepal width. Now let's come back again here. Now let's say that I want to do now a statistics. I want the statistics now to be what? To be chi-square testing. So I will say now that I will pipe all this within the add p. Now when I add the p, I have to say that the test that I want, I will say that the test that I want should be a list of. Now let's say that when you are coming here, you are realizing that what? I can do chi-square test here and I can do chi-square test for both of them. So if I want to
Yes.
do chi-square test for both categorical variables, here is one categorical variable species, other categorical variable cat sm. So I'll just say the test will be the list of all. I just want to say that all categorical variable I want that you do the chi-square test. So it's instead test is equals to, sorry, test equals to, I'll say all categorical, and then I put bracket inside. Then I'll put this sign, and then I say that one all categorical. I want that you do the chi cure dot test. Then I press enter. Could not find the function all categorical. So it's because I did not spell it very well now. You see, I've said all categorical. So I'll just arrange it again, and then I'll cancel this, and then I put here. So you see that he has calculated a p-value. Now this p-value was calculated based on the Pearson's chi-square test. You understand now? Are you getting? Hello?
Yes, I'm there.
Yes. So all this p-value was
You see that?
calculated based on
It
the
is here.
Pearson's chi-square. Now let's come back. Let's say that I want only species to be calculated by Pearson's chi-square, and then I want the cat SL to be calculated by Fisher test. I'll just come here, and then unlike to say all categorical variables, I'll instead say for species, for species, you express it in terms of chi-square test. Then I put comma. Then I instead say for cat SL. For cat SL, you express it in terms of, let's say I want that you express in terms of Fisher dot test for the chi-square test. So you realize that what this p-value is going to be calculated based on the Pearson's chi-square, while this other p-value is going to be calculated based on the Fisher exact test. You understand now?
Yes.
Okay. So that's a revision way how to do the Fisher and the chi-square test. Now let's visualize now how to do now what? To do now for the t test, the recursion test, and the all the like. Now we say that t tests are done in terms of means and standard deviation because continuous variables are expressed in terms of means and standard deviations, or they can also be expressed in terms of medians and then interquartile range.
Interpretation.
So when I come here into table summary, I will cancel all this add p because I don't want to do again the fisher test nor this other test. But I want you to understand something. Every time that you say table summary, that you want to evaluate the table summary, and then you include, because species and cat sl were categorical, were characters, you understand now, they are characters. Species and cat xl, they are characters. That's why when they are calculated, they are considered in the GT summary tables in terms of frequency and percentage. But now let's say that I instead want to um now, let's say that I want to express instead this, the sepal width and the beta length, but I want to express that instead in continuous variables. What should I do? So I'll still include, so I'll include now the sepal dot width, and then I'll include now what again? I'll include the sepal dot length. I want you to see something very important. Now you realize that since the sepal dot width and the sepal dot length, in this case when I said it for species and cat SW, it was expressed in terms of frequency and percentage, you understand now.
Mm-hmm.
But now since sepal dot length and sepal dot width are characterized in terms of they are stored with variable type double. You remember what's double now as variable type, so that variable type double correspond to real numbers. You remember now.
Yes.
Now since they are double, that's why the table summary will consider them in terms of means, median and interquartile range. And the simple reason why it is considered as median and interquartile range is because by default, if you just write table summary and you just want to visualize the code within the table summary, let us see what it's going to show. So you say here that by default, when there is statistics, the list of all continuous variables will be expressed in terms of mean and interquartile range, where the P25 is the 25th interquartile range and the P75 is the 75th interquartile range. But now I'll have to convert again these statistics now and say that now all continuous variables should be expressed in terms of mean and standard deviation. So I'm sure we have done it last time, but this is a revision. So I'll come on the cat SW here, and then I will say comma after include. I will say now that was statistic equals to what? Equals to all statistic equals to, let me visualize it. They say statistic equals to the list. Mhm. Statistic equals to the list of all
Très simple monter. Je ne vois pas.
the list of all continuous. The list of all continuous. Now express now this all continuous in terms of what? In terms of mean, in terms of uh, mean and standard deviation. Let us visualize again because you have to make sure that your code is exactly what is all that is within the parentheses. In terms of mean, so I'll put here again bracket, and the standard deviation. I'll put S like this. So you see here now that large Before, yeah, it was expressed in terms of median and interquartile range. But now here is expressed in terms of means and standard deviation. You understand now?
Mm-hmm.
Now I want now to do a statistical test. And that statistical test that I want to do is the t test. Let's say I want to do a t test. I will now go and pipe all this within what RP. And then within that RP, I say that the test will be equals to what? Let's say that I want that all the continuous variables. I'll say that the test is equals to list of, I want that all continuous variables, all continuous should be expressed, should be calculated by the t test. So I write all continuous and then I write t test as such. So you see here that one for sepal width, you see that the p-value, sepal length, p-value, all that was calculated by the two sample t-test. That Welch two sample t-test is the same as the student t-test. So now that's in case where I want I want to use the student t-test. Now let's say that I want instead to use let's say that I instead want to use the Wilcoxon test. Hmm? So I'll just come here. Unlike saying t-test, I'll instead say Wilcoxon dot test. So it shows you an error, object Wilcoxon not found. So let us just visualize what to say because I've said all this here. Yes, in order to use a Wilcoxon test, instead say Wilcox dot test. In order to use a Kuskawali test, instead say Kuska dot test. You have it all here. So for the Wilcoxon test, you instead write at the place of Wilcoxon, you instead say Wilcox. So that's it. You understand now?
Yes.
Okay. So you have done that all in within R. Now let's try to do it again within Python. You understand now?
D'accord.
So the first thing, what was the major library that was involved with uploading things from Excel?
Import.
We import what?
Import Excel.
No, we import pandas as PD.
Okay, import from.
So let's just wait the import pandas as PD. Now when you import, I'll say iris 0. I'll assign it to what? I'll assign it to PD dot. We said that here is an object oriented programming. So we say PD dot read what? Read Excel. And then you put in bracket. You go and put an you first put an R sign, then you put everything that you had to check. So let us go and collect again everything that we have taken here. So here it is. Okay, but now here I'll instead convert and put it back as backslash. That's going to show you an error. Okay. So now iris 0 has come out. Now I can say iris 0 dot head will show me the head of the iris 0. Now I've told you last time that when you want to visualize, let's say I want instead to visualize this iris 0 now within another web page, just like I'm visualizing it with the R data set. So I've said that what you do is that what you import detail as dt. Hmm? You import detail as dt. So let's just wait. Hello, Tijani, are you there? Hello, Tijani, join là. Okay, good. Now, when he has done like that, the next thing that you can do, I will now say that I want to visualize this other data set. So I'll say dt dot show. I show what? I show now that data set iris 0 dot open browser. So it tells you that the browser is open within this http blah 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 detail.me. So I'll just copy this and then I paste it here. So you see here well that the data set, the category SW has been shown very well as clearly. Now I want to visual. I want to do I want to do again the same thing like with the iris data set that I did with R. We did chi-square testing, T testing, and all the like. So I said that in order to do that, we are going to use what is called table one. So I'm going to import table one library as TB. So after importing table one library as TB, the next thing that I will do now is to do now to visualize now the table that is going to help us in doing that. So what are the table, just like the GT summary table that are going to help us to visualize? We are going to come here back using our code. And we have said that for the chi-square, you have to say import table one. When you import table one, you have categorical variables, then you have p-value. But the most important thing, as easy one to learn, you just say question mark, or I just want to visualize the help of the TB table one. So the help of the TB table one is going to tell you that within that TB table one, we have different arguments. The first argument will be the data. In this case, will be iris 0. Second argument will be the column. Now the column, they say the list of column in the data to be included in the final table. So actually when they are saying columns like that, that is the columns in the data within the final table. Now the categorical, they are saying that now the list of those columns which are categorical variables. For continuous variables, the list of those columns which are going to be continuous variables. And then they ask you to group by what. Are you getting? And then you specify if it is not normal. Now, non-normal, list of columns that contain non-normally distributed variables. When I say non-normally distributed variables, so there are those columns that we are going to now do. We are now going. It's going to do the other testing, like the recursion test and the other test. You understand now? And now, if you want to visualize the test that has been done, you write H H test H test name. So we have H test name. Hello?
Hello, doctor.
Okay, great. So I was trying to do now those statistical tests like that within Python. So
Okay.
so we are now on it. So we said that the major module that is going to help us to do that within Python is going to be called table one module. So and this is how we use the table one module. You write the help tb.table one. It's going to tell you that the first thing to put within the table one module will be the data. After putting the data, you put the columns. After putting the columns, say among those columns, which one is going to be categorical variable, which one is going to be continuous variable, which one is going to be group by, which one is going to be the p value and all the like. So now let's come back to the writing. So I'll say that so that I say cross tab. So the cross tab will be equals to the table one. Table one. I'm going to put the iris data set, iris 0 data set. Now I will now include the columns. The columns are actually, so make sure that you spell it well. So it's an S, columns, S. So columns is equals to what? So columns is equals to, now I'm going to put in the list of those columns. The list of those columns are what? The list was what? Was species and category SW. So I'll put, but make sure that you should know, because here when you were viewing this other data set within the detail, you say species is in capital letter, correct? Category SW is small letter and this small letter, so it's good. So I'll write species, then comma, cat SW. Then I want it to be grouped by, so I'll write group. You say that I want it to be grouped by what? I want it to be grouped by the cat SL. Understand now?
Yes.
So after being grouped by cat SL, I'll just press OK. Now I want to visualize this cross tab. So if I want to visualize this cross tab within the command line, I'll just write cross tab like that. You see that he has shown the cross tab within the command line, but it's going to be poorly generated. Now, if I want
Mm.
to visualize now this cluster within a web page, I will now write the detail, the dt dot show what? Show cluster. Now, since this is table one, I'll write table one dot, I will reset the index and then I close. Then I say that I want to put it dot open browser. So you see, it has shown it again on a new web page. So you see here at the species, you have Setosa, versicolor, virginica, and they were grouped among those two groups there. But here you realize that there is no p-value. Now I want to put down the p-value. What should I say? I should just take again that cross tab above there. Then I will just put comma. Here we don't write add p, no. Here we instead write p-val equals to true.
What's to?
Equals to true to say that you want to
Okay.
add p-value. You write p-value is equals to true. Now the next thing, I want that after, as I've said last time, I've told you that word in R, when you are writing the p-value is calculated based on what you decide. You can say that you want to do the Fisher test, you can say that you want to do the chi-square test, but that's in R.
Mm-hmm.
But in Python, you are not capable of deciding which test is going to be performed. The machine is going to decide for you. So
That,
when the machine decide for you, you want now to know which test was performed. So you write each test name equals to also true. Now I take again that this thing dt show. Okay, good. Now you realize that what? The p-value has been calculated, and the p-value was calculated both with the chi-square
that's
method. You understand?
why.
Now I'll do now the same thing with the continuous variables. So I'll take here, but now I'll group it by that. But now I'll say that the columns will not be species. The columns will instead be what? Will be what? Sepal width and sepal length. So I'll write sepal dot length and then here sepal dot width. Now I go up, dt show. Now here you realize here that what? This thing was expressed in terms of frequency and percentages. Percentage are in bracket, frequency are out here. But yes, since now the columns are sepal width and sepal length, they are expressed in terms of means and standard deviation. Here you realize that it was expressed in terms of frequency and percentage. But now here it's instead expressed in terms of means and standard deviation. Because you know that sepal width and sepal length were doubles. In the case, doubles in Python is instead called float. And float and doubles correspond to real numbers. So it's expressed now in terms of means and standard deviation. And then you see that the test that is performed here is the Welsh t-test. Now let's say that I instead want to instead perform the non-parametric test of the t-test. If I want to perform the non-parametric test of the t-test, I will instead say that word because there is one of, when you realize of one of the parameters of this thing say that what? Non-normal. The non-normal here correspond to the list of all the columns that contain non-normal variables. So if I say that there that one, let's say that I say that the non-normal curve, the non-normal variable here is sepal length. Let's visualize that what it's going to do. So I'll write non-normal. Let me first charge the machine. I'll say no normal is equals to, I'll put it within a list of what? I see that within it we have the sepal dot length. Now I want to visualize again that. Now we see very well. Now you realize that what? You realize sepal dot length. Since I said that the sepal dot length was not normally distributed, see the test that was performed. Test that was performed was a Kruskal-Wallis test. And you remember that I said either it is the Man-Whitney U test, or it is the Wilcoxon test, or it is the
Mm-hmm.
Kruskal-Wallis test, which are corresponding known parametric tests for the T test. Understand?
Yes.
So that's why the Kruskal-Wallis test was used automatically here. Now let's do a bit the same thing now with not normal, but unlike that, we instead use it inside the species here, species and categorical variables. Now we say H test name, and then here now we instead say that the known normal is equals
Ask
to,
someone.
we say that the known normal
Collecting.
is equals to species.
Yes.
Now we use
Nyako.
again that.
Like, okay, you have it, please. Okay, Nyako. Don't disturb me, Nyako.
Now, though I said that the known normal is species, you see that they see the chi-square test that was performed. You understand?
Mm-hmm.
Because I've told you that what? I've told you that there are different chi-square tests. There is a Pearson's chi-square, there is a Weyer's chi-square, there is even the cross chi-square. There are many chi-squares. And there are chi-squares for non-normal distributions. You understand me?
Yes.
Yes, that's why see here the chi-square was maintained. Okay, so I'm sure you have already revised all the notes of doing statistical tests. So from now, I'm sure that you are capable of doing data analysis with all data sets that you are being given with. You understanding now? Are you
You
getting?
just need practice. I'll just take my time and practice all of that.
Yes. Now, what we are going to do is another important aspect that most many data scientists don't know how to practice it. So this one is associating now the risk factors of a particular event to occur. How can an outcome occur? So I will just start
Mm-hmm.
by having a notepad and then first explaining before we go into the code. This is this part is extremely important, particularly when you want to enter into a research, because you have to know how an event can occur. What's the probability for an event to occur? Okay, so now here we are going to discuss now on probabilities and events to occur. Now you need to know that what you need to know that when you toss a die, um there is a probability for an event to occur. The probability for you to have a head is going to be half. The probability for you to have a tail is going to be half. You understand now?
A coin or a die?
Yes, you toss the coin, sorry. So you have a
Coin. Mm.
probability for you to have a head, you have a probability to have a tail. So when you have that probability is going to be always half. So you are going to have two major events that are going to occur. You understand?
Mm-hmm.
Exactly. Now, when you have two major events that are occurring, it means that the events are going to be expressed in terms of what is called binomial. So when you have two major events that are going to occur, two, it is said to be binomial events. And binomial events respect what is called the logistic regression. So when there are only two events for you to occur, are you getting? Let's say that when you toss a die, there can be what the way of tossing. If you toss,
So,
let's say that you toss with the thumb or you toss with the index finger. You understand now?
mm-hmm.
You can have also the what the climate, the temperature
Yeah.
of the surrounding environment. You can have what if the sex of the person that's toasting is a male or a female. I'm just taking examples anyhow. If the sex of the person that is toasting is a male or a female, if the age of the person that is toasting is young or old, all that may be affecting the event, and those events are going to be binomial. Are you getting? So
Like
we are
now,
going to respect what is called a logistic regression. Are you getting?
yes.
Now, the next thing again, in a case of when you are toasting now a die, are you getting?
Mm-hmm.
When you are toasting a die, you are capable of having six outcomes. Either you have a one, you have a two, you have a three, you have a four, you have a five, you have a six. So toasting a die. So you have multiple outcomes also. Are you getting?
Sure.
So when you have multiple outcomes now with a die, but those outcomes they are not binomial, they are multiple. But since still they are multiple, but they are discrete. You understand?
Why?
So they are multiple, but in addition to multiple, they are discrete multiple. It means that you can either have a one, you have a two, you have a three, you have a four, you have a five, or you have a six. So let us take an event now in binomial logistic regression. Generally, you can have two events. Let's say that if a particular thing is going to result to death or alive, are you getting? When you are
Yeah.
at the end of a particular event, you are going to have death or alive. You see that it's going to respect the binomial outcome. You understand now?
Yanzu ma program
Very
yake
good.
yi. Sure.
Now let's say that in the other case, let's say that you want to evaluate now if a patient is within the three for the let's say the three categories of heart failure, or the four New York Heart Association of dyspnea. You understand? You have dyspnea class 1, dyspnea class 2, class 3, class 4. Now, let's say that you want to evaluate what are the factors affecting the different dyspnea classifications. If somebody is old age, if somebody is sex male, if somebody had heart failure in the past, if somebody, you realize that in this case we have four outcomes, and those outcomes
Wait.
are discrete. You understand me? Are you getting?
Sure.
Now, in this case, you're not going to use a logistic regression because that's not a binomial event. There you have a quaternal event. So you have four major events. You understand now? Since you have four events and they are all discrete, you are now going to use instead a regression which is called the Poisson regression. Either the Poisson regression or the Gaussian regression. So we are going to use now this regression when you have multiple discrete events. You understand now? Are you getting me?
You see that one? Sure.
Good. Now the next thing, let's say that you want to evaluate the different factors affecting the glomerular filtration rate. Now glomerular filtration rate is a continuous variable. Let's say that you have the age of the patient, you have the sex of the patient, you have different this thing. You have the body mass index of the patient, all the like. One when you want to evaluate if it's going to affect now a continuous variable. So when the event when the event is a continuous variable, when the event is a continuous variable, in this case, you are going to have multiple outcomes which are within a certain element. Let's say that you want to evaluate factors affecting the body temperature of somebody. You want to evaluate the factors affecting the body temperature of somebody. Now, temperature is a continuous variable. To evaluate now the factors affecting the body temperature, you must you must use the outcome which is continuous variable. So in this case, the regression model that is going to be used is called a linear regression model. You understand now?
Mm-hmm.
So those are the different regression models. Now you have other regression models. Now those other regression models are going to learn that if you are going to browse at this example server. You have Bayesian models. You have the Bayesian models. You have the Maxwell model. This Maxwell model is associated with frequency motion of atoms. So we have different models again that are used in physics, in mathematics, and all the like. But for our data science course, we're just going to mostly be involved with two major ones: this logistic regression and the linear regression model. You understand now? Are you getting me?
Yeah. You see that?
Okay, so we are going to now have the codes for us to perform each of those models. So, how do we do a linear regression? You have to know that a logistic regression and a linear regression, we use the same code. The same code that is used for logistic regression is that same code that is used for linear regression. And now, for the regression code, we are going to place it within the table summary function, the table regression function, sorry. We're going to put it within the table regression function. And now the major function that is going to help you to do that is this, the LM, this here. So I'm going to show you on how to perform that. Okay, so let's start. Are you with me?
Why, sure.
Okay. So the first thing first, I'm going to use the iris 0 dataset. Then I will pipe it within the major model that is going to be used. The model that is used for a simple linear regression is going to be the LMYX. Y is the Y value and X is the X value. Or I can just first ask how to use the LM. So LM is actually the linear regression model. LM states that when you put a formula, then you put the data set, then you have the subset and all the like. Now the formula has a way of doing it. If you go to the examples here, you see that when you want to put the formula, this is how you put it. And the first one is the y value and the second one is the x value. The y value is always the outcome. The x value is always the event. This is always the variable. You understand?
Yes.
Okay. So I'll come back here. So I'll write iris data set. Using the iris data set, I will pipe it in a linear model. In that linear model, I'll put the formula. Now let's say that what I want to see, you know that in linear model, the outcome must be what? The outcome must be continuous variable, and then the variable must be continuous variable. In this case, let's say I want to find the relationship between the sepal length and then the sepal width. And now let's say that I'm saying that what the sepal length is what affects the sepal width. You understand now? Or let's say that I say that the sepal length and the sepal width affect both the petal length. So I'll put the formula. I'll say that what x, we said y against x. So I'll come here. Have petal length here. Alright, petal dot. Alright, petal dot length. And then I'll associate it with what? Sepal dot length. Let me visualize it again better.
There's nothing in the fridge. I saw rice now. I can warm it after the question. Hmm? You're continuing. You're doing.
Okay, let me first try putting the petal length within another variable, and then I put this because it's telling you that you cannot coerce the petal length to that. So I'm going to put this within another variable first. So I'll call it petal PL. PL will correspond to what? It will correspond to the iris 0, the iris 0, petal length. Now the SL will correspond to what? The SL will correspond to the iris 0,
Sepal
sepal length. Now I'm going to do again the same thing up here, but with the SPL and the SL. Just so I cannot coerce. C'est pas pourquoi ça dérange, hein. Um, je vais encore recommencer, mais avec plutôt le. On va say LM separ length. Petal dot length. And I say the data set is equals always 0. What is this?
Yau ne Tinubu ya zo Bauchi ne. Ya zo taziya.
Fala macho putain.
Dan Allah. Inna lillahi wa inna ilaihi raji'un. Ta Allah ka ji tsoron Allah. Kai dai baka ji ba dai.
Ah, okay. You see the error that I was making.
Amma ka bincika.
Dr. Tijani,
Why?
I was making an error because I was putting the quotation. Let us
Double
just
quotation.
start here and remove the quotation. When I put the quotation, there is an error. So actually, that's that.
Yanzu Ahlus Sunna an kasa
So
Ahlus
that's
Sunna.
a linear regression model. Now let's say that I
Mm-hmm.
want to have it again. Let's say with
Banza. Ke ma ko sallama ke. Wallahi. Wallahi ko sallama ke. Wannan mutum ya Allah na kuma barka ku sani.
oh,
Shi ne nake da dauci saboda ko wallahi
so if I
tallahi.
want, let's say that if I want to, when I want to
Mm-hmm.
evaluate sepal length, the sepal length, this is how the sepal length affect the petal length, and this is how the
Mm-hmm.
sepal width affect the petal width. So we have what is called the beta. Beta is it tells you if it's positive or negative depending on the population. Sepal length, the larger the sepal
Mm-hmm.
length, it means that since the beta is positive here, the larger the sepal length, the larger the petal length. You understand?
C'est ça qu'on appelle le hôte. Ou ça,
No,
c'est
it's
pas
not
le
the
hôte,
odd
non?
ratio. The odd ratio is not this one. Odd ratio is calculated from the logistic regression, and when you do e raised to the power this, that's it helps you to calculate the odd ratio.
Mm-hmm.
Yes, but in this case, this is not the odd ratio. In this case, this is evaluating the how the sepal length and the sepal width is going to affect the petal length. Since the beta here for the sepal
Mm-hmm.
length is positive, it means that the larger the sepal length, the larger the petal length. And yes, this is negative. It means that the larger the sepal width, the smaller the petal length. And all of them are
Mm-hmm.
statistically significant. You understand
I
me?
see.
So that's how
Mm-hmm.
we do it. I was making a mistake because I was placing the quotation. So actually the formula is you write LM, so to say linear model, and then you put the petal length, and then you correspond it to what? You say petal length, here's the Y value. then you put this sign, approximation sign, then you put the sepal length. Sepal length plus, let's say that I want to say multiple x values. I'm going to put sepal length, and then I'm going to put plus, then I put the comma, and then I put the iris data set. Now let's imagine that I remove this iris data set and then I put it iris data set in the beginning. So I'll write iris 0. I pipe it within. Now this is, it tells you the same thing. It is impossible for you to coerce machine. So you have to place the iris data set within the code, or you can just put comma and then you say data is equals to dot. It helps you to know that that is iris data set. Okay, I see where the error was coming from.
What
You know
I
that
say,
for the iris, you don't pipe the iris 0 within the linear regression model like that. It asks you to put it within the linear regression model. That's what it tells you. Now you can also use the GLM. If you don't want to use LM, you can also use GLM here. GLM and LM correspond to the same thing. It's just to say that is still linear regression model. So it's going to give you the same thing. Are you understanding? Are you understanding
wait,
me?
you see how you talk?
Okay, good. Now let's say that I want to calculate now the logistic regression model. Now for logistic regression model, the first thing is that what? The outcome has to be binary. Are you understanding? Let us try. Let's say that I want to evaluate the category SW and I want to do a logistic regression model with the category SW. Let us visualize it here. So for logistic regression model,
Yes,
we do that what? We use a table summary, we use
you see how you talk?
GLM, you have the Y, you have the X1, X2, and then you have to mention that it's a family binomial.
Yaran sannan baka biya kuɗi ya
Now come here,
wannan
alright, what?
Muniru, wannan farin yaron Muniru, za a gani
So alright,
ana tattauna da shi, yana ba da
linear
shawara.
model, or I'll prefer generalized linear model. So I'll put what? I'll put, let's say that I want the outcome to be what? Cat SW, you understand now?
Yes.
Cat SW. The cat SW is going to be, no, cat SL. Cat SL is going to be the Y, the outcome. Now, specie and cat SW are going to be the continuous variables.
Kafin a ce Allah ya ji kansa.
So I'm going to add cat SW, comma, species. Both of them are going to be the um the 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 variables. Then I'll put comma. What do I say again? I have to put family equals to binomial. When I say family is equals to binomial here, I'm mentioning that I am using the logistic regression model. Then I put comma, data that we use will be the iris 0 dataset. So the data that we use will be the iris 0 dataset. Then I will pipe it all
Yeah, I don't know this.
within the table regression. So weight must be numeric vector. Okay. So here there is an error. This error is that what? The cat SW is not expressed in terms of numeric vector. Generally, we have to know that what? In a logistic regression model, we must express the outcome in terms of either 0 or 1. You understand now?
Mm-hmm.
It should not be, because in this case, cat SL is expressed in terms of high and small sepal length. So you have to change that cat SL and make sure that it becomes now um, um, it is 0 and 1. You understand now?
Oui.
collecting the
So how do I do it? You remember that there was a function last time that we did. So I'll write ct will be equals to what? Ct will be assigned to what? I'll write if else. I'll now take what? If else what?
maybe I will
Remember
combine
in the if else we place the data set first. Or let me just visualize how to use again the if else. So in the if else we have the test and object blah 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 blah. So let me see an example. So
quickly
square if else.
procrastination. Maybe you know your Python.
I'm doing good.
So test an object which can be coerced. Why? Return the value, the test, blah blah blah. Let us visualize here. Okay. So I'll say CT will correspond to what? If else, I'll take what? The iris.
These days,
It was what?
one
Iris cat SL now.
useless.
Not so.
Useless.
The iris cat SL. Now if the iris cat SL is equals to, let me just come and check the names here again.
The quality of the inside you are
If the
this
iris cat SL is equals to small sepal length, it is
has
0. If iris cat SL is equals to small sepal length, make sure that it is well spelled. Sepal length. I'll come back again and check if the spelling is well. Yes, capital S, small s length. Yes, correct. Small sepal length. I will say that it is 0, else it will be 1. Now come again on that GT summary function. Then I say instead CT. No. What I will do is that I will first bind that CT with this in the new iris 0 data set. I instead say now the IR data set, I'll call it IR data set, will have the C bind of the iris 0 and what is not so.
ai ina da labari kana can amma ina samun labarin an ce wani
What's happening?
an ce mu ma ɗan majalisar ko aka ce da ana
Length
kokari
of CT
haka
0.
eh to mutum ai karshe mutum ya fara zanna kusa damun dalilan da yake sa ya kushe kusa politics ya zama fake. To Allah ce kuɗin ya yi yawa ya sa da kuɗin iya abin da zai nema shi ne adalci. Ai normal me yasa ka tare mm, eh,
What is this nonsense?
eh, eh.
Hmm. This is your city. Okay, good. Now I'm going to say my city.
The Joker.
Weight as the numeric vector.
Wallahi ni ba wani jauya ba ne, amma gaskiya ba dan karyata ka. Kaga wannan matsalar muna da shi har da Ibrahim har ya mun yi faɗa mun da ni. Kaga dai gari ɗaya muke da shi amma na rantsi da Allah sai ni ba na karya wai akan wannan ɗin. Dalili na shi ne ina gaya masa wallahi wata rana ba ina ganin kiran nan da kake ai to akan me zan yi karya.
So that's the reason why it's not working now. Because I did not put
Na sani
exponentiate
ina
equals to true.
ko da cewa za ka samu attention ɗina kuma wallahi wani lokaci ina da very quiet ni kaɗai ma a ɗaki amma wallahi ba zan iya discussion ba. Yawwa.
So
To ai
the error comes because I did not put exponentiate equals to true. So I must make sure that here within the table I should always put x
to kuma gaskiya ya da
shade
zai mu musamman a message ne ko SMS ko na WhatsApp duk
that
jima wanda
exponentiate is because yes, that's it.
kuma irin jima wanda
We
ba
have the
in dai na
particular
samu
SW. When you put
ya
exponentiate equals to true, it's going to produce the odd ratio.
yana buƙatar ka
So
irin
now
nan
if I put exponentiate equals to false,
za ka yi wani abu makamancin wannan to kaga wani kuskure ne sosai wani ma shi ne last kai ne last hope nasa
so I will
kaga
put again here is yes, table summary like this. There's your error. So I'll write exponentiate equals to true. Just see tells you that they both have error. Yes, correct. So you have to put cat plus species. This is the error. This
ko
cat
kuma is too
species like this.
abin da zai zama wani mai amfani ba.
So it is GTLM, correct. So that's the code that I show.
Alamun
You see,
struggle ɗin ke nan
that's
ruwa
when
da
the
oga. Ana
exponentiate.
wahala.
False.
Then why is it that the species is bad pattern? Let me remove species.
Once in a while. Okay.
So you see, this is the formula. So that's when I put exponentiate equals to true. Exponentiate equals to true is going to help you calculate the odd ratio. So we have
Mm.
4.39 and all the like. That's the exponential equals to true. It tells you that what? It tells you that so it's going to calculate the event for this. Actually, this table tells you the event for a one to occur because I've said that what when I was trying to
Magana
calculate here,
amin
I've
kai
said the
kai
zero correspond to what? Small sepal length, not so, and then one corresponds to large sepal length. So the linear regression models only evaluate for a one to occur. You understand now?
Yeah.
It means that what? It means that here the probability here is the probability for a one to occur. It tells you that what? It tells you that comparing small sepal with respect to large sepal width, the
yaron ya je kuwa.
probability for a large sepal length with a small sepal width to occur is going to be higher. You
Ba
understand now?
Na manta ba maganar na
Mhm.
wannan kaya nake ba ma.
because small
Ni na
sepal
manta
length compared to the large sepal width
shi
for the
kayan nan
sepal for the petal for the sepal length to occur. So
yaro.
that's it.
Mhm.
It's larger. So it
That's
is the
okay.
probability for a one to occur. So that's it.
Ai
Now
ban ji
that
ba.
is for the logistic regression. So when you want to do a logistic regression, that's how you do it. Now let's say that I want to do a logistic regression with the species.
Ko wanda
So
aka
instead
yi a
cancel it
government
here,
hospital.
and then I'll do plus species.
Yana program na World Trade ɗin nan ne.
So bread value, it tells you that this species was not among. So I'll just put, make sure that you don't make errors with this thing.
Eh,
You see that this with species. So with species we
eh,
have what? Setosa versicolor virginica. So virginica, you see that it has a higher odds. When you have
program ɗin.
Mhm.
versicolor, versicolor has a higher odds for it to have what? For it to have a large sepal length.
Ya
You understand now?
Eh.
wallahi ni ko
So
bai ma kira ni.
versicolor has a higher odds for it to have a large sepal length as compared to setosa. Virginica
Ka
again have a larger sepal,
san
larger probability for you to have a deep sepal length compared to setosa. You understand now?
Why?
kanin X
Yes,
ɗina
that's
ne.
it. So and then they are statistically significant. So you see, when you do one by one like that, so when I'm doing,
Wallahi
see, I did here
ina
cat
mamaki.
SW, then I did with species.
Babu
Now let's say
surprise
that I
ta
am doing it now with another one
fi
again.
Allah.
A DPLM,
Ran ce
I do, let's say now with another variable, another, let's say I take the sepal width to do the logistic regression model. I'll say sepal dot width. So you see, with sepal dot width, I have again another one. You understand now? Are you getting? Hello?
You see that, doctor?
Okay. So you see that I've had with cat SW, I had with species, I've had with sepal width. So that one is called what is called a binary bivariate analysis. So what I'm doing like that, I'm doing a logistic regression model with a bivariate analysis when it is one variable after the other. You understand now?
Mhm.
That's a bivariate analysis. Now, when want to do a multivariate analysis, I will combine all of them to each other. So I will take, let's see, the first one. So the first one was CT cat SW, you understand now?
Oui.
Then I'll add it. I'll add it to species. Then I'll add it again to what? To sepal width. You understand me? So it means that in this case, I'm doing now a multivariate
Multivariate.
analysis. You understand now?
Oui.
I'm doing a multivariate analysis with that. So the first one was bivariate analysis with logistic regression model. The second one now is the multivariate analysis. So this one now has done me a multivariate analysis. Though he
Et on
has
parlait de
taken
univariate quand, docteur?
ah
C'est quand qu'on parlait de univariate?
univariate analysis is only when you want to evaluate the means and standard deviation and the frequency of
Ok.
percentages. You
C'est
are
ça
only
qu'on appelle
analyzing one
univariate.
variable after the other. Bivariate
Ok.
analysis is you are analyzing two variables together.
Mhm.
Mhm. In this case, I'm analyzing CT and sepal width together. That's why it's called
Mhm.
bivariate analysis.
Multivariate maintenant à partir de 3 montants.
Exactly. So now
Ok.
in this case, it tells you that there were 49 errors and warning to see them. So actually, it means that this it could not, though it brought out the formula, it's not very good. It's not clean. You understand now?
Mhm.
So that's that. So we can already say that you know how to do logistic regression model. So So I will send the note in the group. So this is how
D'accord.
we do the logistic regression model. Other models, you have also the correlation. You can decide to correlate one variable to the other. So if you want to correlate, you use the core test. So let's say that, so I'll use core dot test. Then let's say that I want to correlate iris sepal length. I want to correlate to what? I come back. Let's say I want to correlate the iris sepal length to that sepal width. I put comma iris. You see, it brings you out the correlation formula. You understand now? So you have Pearson product correlation data, blah blah blah. There's the t value is this, that is that, and all the like. You can also decide to put that core. And let's say that I want to pipe it within a TBL summary. I'm not sure it's going to work like that. Let's just try. Yes, it told you an error. So actually, it tells you the correlation. So you have seen here that the correlation is a negative correlation between the sepal length and the sepal width. Tells that's a
Mm-hmm.
negative correlation. That's negative 0.11. So you have already all the methods. So here today we have seen the how to do a linear regression, how to do a logistic regression, and how to do a correlation with R. Now
Mm-hmm.
let's do now the same thing with Python. Okay, now let's do the same thing with Python. So we first start with the linear regression. So the linear regression with Python, you have to import different modules. We have the major one that is involved even with Python is the start model .api as sm. That's the major module that is going to be used when you want to do the logistic regression, the linear regression, and all the like. So you are going to put the predictors within an X column. You put all the predictors within an X column, or you say that it is a numeric variable. So you transform now categorical variable to numerical variables, dummies. This turn the species into zeros and ones, and then add constant force. This presents singular SMPT. So let us start. So you have to respect this step. In Python is a bit complicated, but you have to know all of them. So this is the major code that is even used when you want to visualize a linear regression model. It is SMOLSY X, and then you put a fit. Are you understanding?
Mm-hmm.
This is the major code here. Okay. So the first thing is that what I'm going to create the X variables. So let's say that I'll first say that the Y variable will correspond to, let's say I want that the Y variable should be the iris 0. I want to bring out what? I want to bring the cat. No, it will not be category. This is linear regression. This is linear regression. We just say sepal dot length. So the y is sepal dot length. Now I'll say x will correspond to what? Iris 0. Then I'll put a list. It will be a list of what? will be a list of the sepal dot width comma will be petal dot width, and that's the x. Tells you none of the index sepal z type are okay. So error. You have to put a column here and then you put a column here. See, then when you do a small mistake, only spoils everything. Now you come back again. The major code that was involved to do that was called the SMOLS. Now the SM was from the import start model API. So I have to import this model. And we said that you can also change this iris S code. You put them into numeric dummies. But I think that
You
this numeric
never
dummies
take
are that
no.
pardon?
Me no. Huh? Hmm? You never
These numeric dummies are particularly used when you are working with categorical variables and all the like. Well, that's when you want to do a logistic regression model. So I'll come back here. Now I will say that I want to import stats. You import stat model dot a blah 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 as sm dot api as sm. Now you put sm dot od. So let us come back here. So OLS capital letter in bracket. You now put, it tells you to put the y before the x, then you put fit. So you put y comma, no, the y in my case is small y comma, then I put x, then I put dot fit. Unless you are hearing me.
You see that, doctor? You see that, doctor?
Okay, okay.
Si ça te dérange pas, même en journée. Ne pas être aussi.
Moi, ça devait sortir. I don't know why it's coming, not coming out there. Okay, I have to put LM summary. Okay. So at the end of all this, I put LM dot summary so that I see the code. Okay, that's it. That's shown. But I have to make sure that I write it within your final document so that it should not confuse you. Okay. So that's for the linear regression. So linear regression, you have all this that comes out. Now for a logistic regression, you must make sure that you are going to transform two things. You're going to transform the x and the y. The x are going to be transformed to produce the numeric dummy variables, and then the y are going to be transformed into zeros and ones. So that's it there. Um, so let us come back to the logistic regression. We say that what you have to import pandas as PG and you import also stat model. So you are going to have okay. What I can do is that what I can use the NP, the numpy there to convert it into 0 and 1. Are you with me?
And see that, bro.
Okay. You remember that there was a code that we said last time with numpy. So import, let's say, numpy as np. There was a code that was similar to the code in R that we said if else. You remember that code in numpy? Are you getting? Are you remembering that code?
Hello?
Yes. Are you remembering that code in numpy that was involved with putting something in low and high?
In low and high.
Yes.
No, in pass pas que me rappelle.
Okay. So you write y is equals to now you write np dot what dot when now let's say that when iris
It's greater than.
we take which iris, let's say that we are working with say with iris cat sw. Now if the iris cat sw is equals to small sepal.
So I'm talking like equals to.
Yes, that's what equals to an enter because this is a conditional statement. This is not the
Okay.
assignment. Why is the assignment?
Okay.
Why this one is a conditional statement? Small
D'accord.
sepal width. If it is small sepal width, then it will be 0. Else put it what? We say it is not when, but it's instead where. Okay, we do not have the iris data set. You have the iris 0 data set. See, it's telling you the corrections that you have to modify. So you have modified the corrections. Now you have the y here completely. Now you should go and find out the x. Now for the x, you have to do the x well, and then you convert now the x to numeric variables by putting it into dummies. Because if I just directly use um, this formula, that logistic regression formula, the sm dot logit yx. Let's say now that I say in this case that the x will correspond to what? Let's say I said the x correspond to the iris will be a list of, let's say, species, and then what again? Let's say cat sm now. No, it's not iris. Iris 0.
The
Okay.
water. Check the water.
Now I put now sm dot logit y comma x. Then I put dot fit dot summary. It tells you that an error, pandas data cannot pass logit np. So that is the reason why it's doing that, because this x is not transformed into dummy variables. You have to first transform that x into dummy variables before you can do the data set. So, and to transform down those x into dummy variables, you have to come back into this code. So you have to first start by putting x here into the x call. After putting x into x call, you write x numeric now is equal to pd dot get dummy of the x, and then you drop first equals to true. Then you say again now x is equals to the sm at constant x as type float. So you transform now those x values as type float. So I'm just going to copy this step and this step and paste it here. Now I'll go up. I'll call it x, and I'll call it x. A small error, yes. Okay, so I could not convert the float of Setosa. Let me just, okay, understand. I'll come back here and then I'll take instead this one. X numeric is instead going to be x. See an error. Okay, good. Now, since I have that, I've converted that. I'll now say now again that code back. Singular matrix. You just made an error. But then you're going to leave it like that then.
C'est ce que moi j'ai proposé, non?
Python là est un peu compliqué.
D'accord.
Mhm.
Merci beaucoup, docteur.
Ok. Mais tu connais
Thank
déjà
you for your
comment
patience.
faire le logistic regression.
Yeah, at my alert, I need to learn this your patient, guy. Thank you.
Oui, tu vas apprendre, tu vas apprendre. Okay. So I think that all that is we have done. Next class is going to be now the data outputting. Understand?
D'accord.
So this is the
Mhm.
data outputting is going to help you now how you can, when you have done the data analysis of somebody, you now output all the data analysis for him to have it within a good research paper.
Mhm.
Okay, we tell you say to next time. Bye bye.
D'accord. Et c'est pas le week-end prochain quand même, il va être un peu busy parce qu'il doit voyager
Okay, il n'y
à
a pas
partir de jeudi. À partir de jeudi jusqu'à, je pense jusqu'à lundi, elle ne veut pas être disponible.
Ok, donc on peut travailler nous alors lundi jusqu'à
Oui.
mercredi.
On peut... Oui. Même le jeudi, je pense qu'on peut travailler.
Ok, on peut travailler lundi jusqu'à jeudi.
D'accord.
Ok, donc, Neta.
Ok, d'accord.